Synaptic vesicles exist in distinct pools, either tethered to the cytoskeleton in a reserve pool or free in the cytoplasm. Some of the free vesicles make their way to the plasma membrane and dock as a series of priming reactions prepares the vesicular and plasma membranes for fusion. The membranes of the synaptic vesicles are drawn together via protein complexes, collectively called snares, that are expressed on the vesicle and presynaptic membrane. When the axon terminal is depolarized, voltage-gated calcium channels open, and calcium ions rush into the axon terminal. Some of the calcium ions bind to a protein on the synaptic vesicle membrane called synaptotagmin. When calcium binds to synaptotagmin on the synaptic vesicles nearest the active zone, the vesicles are drawn even closer to the presynaptic membrane. The vesicles fuse with the axon terminal membrane and release their transmitter cargo into the synaptic cleft. Some of the transmitter molecules bind to special receptor molecules in the postsynaptic membrane. The response of the postsynaptic cell, either excitation or inhibition, depends upon the particular neurotransmitter and receptor combination. For example, the receptor for acetylcholine is permeable to sodium. After binding acetylcholine, the channel opens and sodium ions enter the postsynaptic cell, thereby generating an excitatory postsynaptic response. Transmitters are inactivated or removed rapidly from the synaptic cleft so that transmission is brief and accurately follows the presynaptic input signal. For acetylcholine, an enzyme in the synaptic cleft, acetylcholinesterase, breaks down acetylcholine into choline and acetate. The release of transmitter from the receptors causes the channels to close. Not all transmitters are broken down by enzymes in the synaptic cleft. Many transmitters are rapidly cleared from the synaptic cleft by being taken up into the presynaptic terminal by special proteins called transporters. This process is known as reuptake. Reuptake not only cuts off the synaptic activity promptly, but also allows the terminal to recycle transmitter molecules. The membrane needed for creating synaptic vesicles is also recycled via endocytosis of the presynaptic membrane. The recycled vesicles are refilled with neurotransmitter molecules and are ready for another round of synaptic transmission.